Imagine an almighty robot that can achieve any kind of tasks you can imagine in the physical world. It can walk, it can swim, it can fly, it can wash dish, make pancake for you. What will it look like? And how do we even achieve that? So today, I'm very excited to share about a very relevant topic, using generative AI in the physical world for soft robot co-design. So in recent years, there are very tremendous breakthrough in AI models for natural language processing, computer vision, speech recognition, etc. And these successes are gradually transferred to robotics domain, making robots smarter and smarter. And the key is basically put those advanced large AI models as a brain of the robot. However, if we look at the natural world, creatures not only exhibit intelligence in their brain, but also in their bodies. And there are a lot of research focused on how to draw inspiration from these natural creatures and design robots that can do a lot of amazing jobs, like swimming in the water or navigating in the sand or using its body deformation to manipulate objects. So in silico, through computational methods, our work also found an interesting relation between environment, morphologies, and motions. So for example, like the fish over here, we found that interestingly, although a bit counterintuitive, fish can move quite efficiently on sand because they can lift its torso to reduce the friction while propelling themselves moving forward. Another example here is computational methods automatically find this kind of fish-like streamlined robot design when we want it to swim very efficiently in the water. I would like to propose a complementary path toward building intelligence that can interact with the physical world. So beyond constructing the brain of the robot only, we would like to extend generative AI to also design the body of the robots. So we start from looking at how current generative AI already exhibit intelligence in the digital world, which already has transformed human day-to-day life, including writing emails, creating graphics, or etc. And studies have shown increased productivity and also better task execution with the help of this generative AI. So now, with the previous successful experience, what if we ask ChatGPT to design a robot for us? So when we ask, design a robot that can pick up a fruit, after a few seconds, this is what we got. We got a lot of very cool, creative robot design proposal. I personally like this strawberry crawler a lot. So let's zoom in a bit and see whether, besides its coolness, whether it's actually useful for robot design. So first, we can see that the sand on the top of the robots, it's very thin and brittle. Can it actually hold the mechanical structures of the arm over there? It seems like a bit defies physics. Moreover, fixing both ends of the mechanical arms to the two parts of the robot basically render a useless robot arm because there's no function at all. Finally, how do we even fabricate this extraordinarily vivid strawberry body? What kind of material it is using? So overall, based on what we see here, generative model is cool, but it's definitely not sufficient. So what we are doing at MIT is basically try to find a solution that can incorporate physics and functional specification into the generative process. So let's take generative models that can generate 3D assets like meshes or point clouds with physics-based simulation that provides guidance of what kind of shape of the robot can be or how to place actuators to, for example, better pick up objects. We can then fabricate the robot in the real world that's generated by the generative AI pipeline. So overall, if we want to design a robot that can walk, we can first use our generative AI-powered robot design pipeline to grow the robot from noise. And throughout the generation process, we leverage physical simulations to provide guidance on how to walk. And finally, we can fabricate the robot in the real world. We can use the exact same pipeline, just changing the specification, to design a robot that can pick things up. So this leads us to a gripper-like robots that can pick up things in both simulation and the real world. And there's another example of asking the generative model to design a robot that can move objects. And this gives this thin, flat robots that can crawl and then drag the objects. One thing I want to highlight here is that this generative AI pipeline tremendously offloads human efforts to machine computation, drastically reducing like a multi-day manual process into a 1 to 2 hours human time. Toward more complex generative AI-powered robot design, we provide another insight. Design like a human expert with knowledge base and abstract reasoning using existing robot design toolbox. Suppose we want to design a walking teapot here. We can use large language model to reason about what kind of parts which can be most suitable for walking. And then we can integrate these selected parts into the generative process, which eventually give us this teapot with 4 legs grown in the bottom. And overall, as a preliminary result, we discuss this very cute walking teapot that can walk slowly in the physical world with much complex mechanism and better consideration of fabrication. So the idea of using AI not only for the brain of the robots, but also its body basically opens up a new possibilities of building strong intelligence that can interact with the real world. On the other hand, the generative AI-powered pipeline can transform how we think of automation with more efficient design and customization, eventually lead to the democratization of not only using the robot, but also developing and making them. And toward this overarching goal of using machine to make machine, I would like to make a call toward not only building generative AI for the digital world, but also for the physical world. And this requires joint effort across a large disciplines, including computer science, mechanical or electrical engineering, material science, and so on. Let's try to redefine how artificial intelligence can be. Thank you.